ways that we've solved these so far. The first way was by graphing, and then sublimation is something totally different. Instead, we use substitution. Okay, so if I have y equals 2x minus 10 and 6x plus 7y equals 10. Right? If I didn't use substitution, do I have either x or y by itself?
No.
I do. What do I have by itself? I have y by itself. So I'm going to take that and I'm going to plug it in for what? I'm going to plug it in for y in the other equation. So I've got 6x plus 7. Now what is my y? 2x minus 10 equals 10. So I have 6x plus 14x minus 70 equals 10. Combine our x's, I get 20x equals 80. Yep, because we're going to add our 70 over there. Then what? Divide by 20, x is 4. So once I have x, what am I going to do with it? I'm going to plug it in up here. So y equals 2 times, what is x? 4 minus 10. So 2 times 4 is minus 10. Negative 2. So my solution point is 4, negative 2. Sounds bad, right? Alright, so today we are going to start solving. So today we are solving systems by elimination today. Every once in a while, you will see this called linear combination. Okay, I usually use elimination, but sometimes in certain books and some teachers will call it linear combination. So I want you to know that those are the same thing. Okay? So our steps to solving by elimination, okay, is the first thing we have to do is make sure our equations are lined up. Okay? Once they're lined up, we can either add or subtract our equations so that we eliminate the variable, okay, with the common coefficient. What on earth is a coefficient? Who wants to take a stab at it? Come on, I know you've learned it. Kind of. It's a part of, if I have 5x, there's a coefficient that's part of this. What's my coefficient? 5 is my coefficient. All it is the number that's hooked onto my variable. Okay? So not even crazy. All it is we want a common or the same coefficient, the same number hooked onto my variable. Okay? After we have that, we're going to solve the equation. And then it's just like what we did yesterday. We're going to substitute that answer into one of the equations and solve it for the other variable. So, in number 1, are my equations lined up? Yep. Okay. In either my x or my y, so do I have y's with the same coefficient or x's with the same coefficient? Yeah, my y's have the same coefficient. What are my my coefficient in y? 1, good. Okay, so if I wanted to cancel out my y's, what would I do? Would I add these equations together or subtract them? It's subtract them, yeah, because what's 1 minus 1? 0. So we get 0 equals, now careful because we're subtracting 3x minus x, 2x. And then be really careful because now I have 4 minus negative 2 plus 6. Good. Okay, because that turns into a 4 plus 2. So be careful that you're watching that. Now I have solve for x. What do I do to solve for x? Subtract 6. I have negative 6 equals 2x. Divide by 2, so x is negative 3. Okay, so I have x, I need what? Y. You can go back, you can plug it into either one of these equations, it doesn't matter which one. Okay, for some reason, because, I don't know, I like to do things the same the other way, I always pick the top equation, but it truly doesn't matter. So if I plug this into the top equation, I have y equals 3 times x, negative 3 plus 4, so 3 times negative 3 is negative 9 plus 4, negative 5. So my point is negative 3, negative 5. Decent? Okay, so if we look at number 2, are they lined up? Yep. Okay, so if they're lined up, what do I have to do? Do I have common coefficient? My x's, right? And how am I going to cancel out my x's? Subtract them. So x minus x gives me 0. 4y minus negative y? 5y, yep, be careful. I'm thinking that a whole slew of us wrote down 3y. Because we've got 4 minus a negative 1 equals 10, yep, so 13 minus 3. So y equals 2. So we gotta divide. Okay, once I have y, what do I do? Plug it in. X plus 4 times, what's y? 2 equals 13, or x plus 8 equals 13, so x equals 5. My solution is 5, comma 2. Be careful with that. Remember, your x always comes first. Flip the page. Let's look at number 5. Are my equations lined up? Yep. Do I have common coefficients? No. I don't, but are they kind of close? Yeah, I've got a 4 and a negative 4, right? Is there a way to cancel out 4 and a negative 4? By adding them. So this time, instead of subtracting my equations, I'm going to add together my equations. Because 4x plus a negative 4x gives me 0, yeah, so that cancels out. So now I have 9y plus 7y gives me 16y equals 16. So y equals 1. Okay, and when I plug it back in now, 4x plus 9 times 1 equals 5. 4x plus what's 9 times 1? 9 equals 5. I think we're all sleeping today. Sleeping? Now what do I do? Subtract 9. So I have 4x equals negative 4. X equals negative 1. So my point is negative 1. Let's see, we might be doing 6, but I gotta look at something here. Let's look at 7. What's my issue with 7? They're not lined up. Alright? So, how can I get them lined up? Here I have x and y on the same side. How can I get x and y on the same side up here? Subtract my 3y because it's positive. So I have x minus 3y equals 11. I have 2x minus 3y equals 16. Common coefficient? Yep. How am I going to get my y's to cancel? What is it? Great, it's subtract. Okay? Because if I add them, what's negative 3 plus negative 3? Negative 6, yeah. So I will give you this. Anytime you have the same sign, so if it's negative and a negative, you're going to have to subtract them to get them to cancel. Anytime you have opposite signs, like a 4 and a negative 4, you're going to add them to get them to cancel. Okay, so I think my S's always go together. Same sign, subtract. Decent? Okay, so if I'm doing this guy, x minus 2x. Yep, negative 1x equals 11 minus 16, negative 5. So x is 5, yep. Okay, and this can get plugged into any equation and you're going to get the correct answer. Okay, I always take my original top one. I don't know why. You could take this one, you could take this one, you could take this one. All of them will give you the right answer. So 5 equals 3y plus 11. What do I have to do? Minus 11, good. So 3y equals negative 6. Y is negative 2. My solution is negative 2. What do you think?